If you remember from before, the addition rule is the probability of one event or another event occurring from the same experiment is equal to the sum of the probability of each event. So the probability of A or B happening equals the probability of A plus the probability of B, given that they are from the same experiment. So a histogram represents the probabilities from a single experiment. So remember before we were talking about heights of trees. So if you're selecting heights of trees and they tend to be from 60 to 70 feet, and you also want to know the probability of being between 75 and 80 feet, those two events are from the same experiment. We're selecting trees and getting their height. So a histogram is always about one variable at a time, or one experiment at a time. Remember, we did histograms in the univariate phase, meaning we're only looking at one variable at a time. And one variable can be thought of as one event. And we can also think of the probability of the histogram as area. So if you think of it that way, it's going to be a little bit easier for you when you're doing these problems, and I'll show you in a little bit. So say we want to know what is the probability of a tree being between 60 and 65 feet or between 80 and 85 feet. So this histogram is of heights of black cherry trees, and selecting trees and getting their height is all one experiment. So we can use the addition rule here, and there's a keyword that we should see, and it's the or there. So we can find the 60 to 65, and we can find the 80 to 85. And then add those two probabilities up to get the probability of a tree being between 60 and 65 feet or between 80 and 85 feet. So what we're going to do is find the probability of the 60 to 65 here, and the probability of the 80 to 85, which is here. So it looks like we have 3 trees in the 60 to 65 feet range and 5 trees in the 80 to 85 range. So 3 and 5. And if you remember, overall we have 31 trees. So over here is this first bar. So this is the 3 and this is the 5. But we want the probability of both happening. So first we find the probability of the 60 to 65, and that's 3 divided by 31, which is 0.0967. Then we add on the probability of it being between 80 and 85 feet, which is 5 divided by 31, and that equals 0.1613. And if we add that together, we will get 0.258. And I wanted you to do it this way so you understand the concept of the probability rule with histograms. But you can double check your answer another way, and you can see that trees that are between 60 and 65 feet or between 80 and 85 feet are 8 of them. So there's 8 of those. 3 plus 5, and you divide that by 31, you'll get about 0.258, and that equals what we got here down here using the probability rule, addition rule.